Implementing Cisco SD WAN solutions. We use it to migrate, for example, from legacy WAN to Cisco SD WAN. Legacy WAN, wide area networks, architectures are facing some major challenges. We need to implement advanced control, data, and app-aware policies. It's with placement of controllers, with deploy of WAN edge devices, multicast, various application quality and experience, which is AppQoE, quality of experience for applications, traffic optimization capabilities. Also with application aware enterprise firewall, IPS, URL filtering, Cisco secure endpoint for centralized networks. SDN is software defined network or in a large scale network. SD-WAN benefits are increased bandwidth, transport independence, improved user experience. SD-WAN solutions is a solution, software-based virtual IP fabric, which builds IPsec unified connectivity. Routing on your service side. There are T-lock extensions for redundancy. It implements control policies and data policy. It's application-aware routing. It's used for a look and design migration. You can migrate branch sites. Software defined for wireless wide area networks, used for deployment on premises, cloud, in multi-cloud, for example, like multi-tenant with AWS and Azure, with there could be several different clouds, and all of this is automated. It's made with automation. It's used for deployment, for transport, and for any location. It could be used for any transport and any location and any deployment. For example, as for transport, it could be done via satellite networks, via internet, MPLS, LTE, and for any location. For example, there could be different branches, cloud, and remote WANs. VPN is virtual private network. It's a method to transfer data in a secure way, which is encrypted. SD-WAN technology addresses the problems and challenges for common WAN deployments. And in Cisco SD-WAN, control plane happen on CPU. Data plane is switching equipment. vManage network management system, which is called NMS. It provides simple but yet powerful set of tools for monitoring network performance. There is management and orchestration. There is a management and orchestration plane, control plane, and data plane. So, data plane, management orchestration plane, control plane. And everything it could use, for example, data plane could use different methods to transfer from different sites, like from branches, campuses, data centers, from clouds, and using different methods like MPLS, internet, 4G, satellite, DNA assurance and analytics. vBond attributes include vBond runs on a virtual machine. vBond is the first point for authentication. vBond distributes a list of vSmart vManage controllers to vManage routers. vBond facilitates net traversal. vBond requires public IP address. It sits behind the first NAT, network address translation. And vBond is highly resilient. So vBond is one of the components for DNA assurance and analytics. We have for management, we have vManage and we have vSmart. Three main components are vBond, vManage, vSmart. vManage is a virtual machine with a single pane of glass for daily operations, multi-tenant with web scale. It manages like day 1 and day 2 operations, and centralized provisioning, troubleshooting, and monitoring. vSmart. vSmart is for control plane. vSmart runs also on a virtual machine. vSmart facilitates fabric discovery. vSmart disseminates the control plane information and distributes the data plane and operation-aware routing policies. vSmart provides scalability. It reduces control plane complexity. vSmart is similar to BGP route reflector. Like BGP is border gateway protocol. vManage, for example, data plane, it's used for BFD, which is bidirectional forwarding. vManage is a component which provides a secure data plane within other vManage routers. vManage establishes a secure control plane with vSmart controller via OMP protocol. vManage implements the data plane and application-aware routing policies. vManage exports performance statistics and leverages traditional routing protocols like OSPF, Open Shortest Path First, BGP, Border Gateway Protocol, and EIGRP protocol, Interior Gateway Protocol. It's available in both physical and virtual form factors. So VH could be like physical and like a virtual. It could be like running on a virtual machine. vManage could be physical and virtual, and programming APIs. It's also a component of Cisco SD WAN solution. Programming API attributes include programmatic control over all aspects of vManage administration and Python scripting. It could be used, for example, for checking authorization and authentication. vAnalytics, it's an optional module. For example, all Cisco SD WAN solutions include vBond, vManage, vSmart, but as for vAnalytics, if you need it, then you can purchase it and pay for it separately. It is, of course, highly advised by Cisco to use, but not all companies use it. But why they would need to use vAnalytics? It's a cloud-based analytic engine, data anonymization, and there is a optional solution element which analyzes fabric telemetry and used for capacity projections, opt-in customer models. vAnalytics offers what if visibility, forecasting, and recommendations. What if module of vAnalytics suggests to find opportunities for balancing costs and performances. Visibility, forecasting, and what about recommendations? Recommendations, they can recommend app-aware routing policies for your case. vAnalytics requires Cisco DNA Advantage subscription, utilization anomaly detection, and it carrier grounded. Cloud deployment only. SD-WAN is divided into two distinct parts: the underlay and overlay networks. Underlay networks, they are infrastructure that connects network devices, and route traffic using traditional routing mechanics. It's underlay. And what about overlay? It's a virtual network that is built on top of underlay network. So underlay is like infrastructure, what we have, and overlay, it's a virtual layer on top of existing network. Overlay is OMP routes. OMP is the control protocol which is used to exchange routing policy and management information. And there are also TLOC routes. Components of OMP routes are TLOC, site IP, label, VPN ID, site ID, label, VPN ID, tag, preference, originator, system, IP, origin protocol, and origin metrics. OMP routes are user prefixes there they learned from within and searching VPN at the local service site. TLOC is a transport locator. Transport location identifier of the next hop of the V route, which is similar to BGP, its next hop attribute. Let's say, for example, there is OMP. It gives certain IP address with the mask. TLOC goes to TLOC with address. It could be public or private, and global public or private IP address, which leads to the internet. If TLOC changes, so we need to remote site one TLOC for ISV. TLOC routes, they have attributes such as a wireless area, wide area network IP, TLOC IP, color. Colors, they are special colors which are, for example, identifying network in a special way. So it could be, for example, Metro Ethernet color. Encapsulation, there could be encapsulation in 99% of the cases. They use IPsec for encapsulation, and TLOC allows independence from individual transport IP addressing. Color restrict will prevent attempt to establish IPsec to TLOC with different color. So they should be having like matching colors. TLOCs are advertised as TLOC routes in the OMP when we encapsulate. TLOC routes in the OMP message, they exist between the edges and vSmart controllers. Traffic goes and gets through the firewall. Path selection algorithm. For example, it works exactly similar to BGP route selection. First, select active route, then select valid OMP route, which should be reachable. Prefer locally sourced OMP route. Prefer route with lower administrative distance. Prefer route with higher OMP preference. Prefer route with higher TLOC preferences. Prefer higher origin. Prefer lowest origin metric. Prefer highest system IP. And the last one, prefer the highest TLOC private address. It's a route selection algorithm. So if the first one matches, we go to second, compare second, we go down. So I will repeat. First, active routes. Second, valid OMP routes. Third, locally sourced OMP route. Then low administrative distance. Then high OMP preference. Then high TLOC preference. Then highest origin. Then lowest origin metric. Then highest system IP. Then highest TLOC private address. Network segmentation and route leaking. Network segmentation and route leaking. Outer header. It's inside UDP. There's components include UDP, which is user datagram protocol, ESP, which is encapsulation security payload, MPLS label. It's not actually used by MPLS. MPLS label, it's an important point, is not actually used by MPLS. Inner header payload data. And when we create VPN, virtual private network, VPN has a label associated within the VPN identifier. It is used to propagate the routing information across the network. VPN ID identifies each VPN on a link. In vSmart, it connects to edges, and there is connectivity by linking routes between connector and connection static OSPF BGP. And please note that in context of Cisco SD WAN, VRF and VPN terms are used interchangeably. VRF and VPN is interchangeably. Sometimes we can say VPN, we can say VRF, and it means the same in context of Cisco SD WAN. BFD in Cisco SD WAN. BFD is bidirectional forwarding detection. It can be used in underlay, and in underlay it provides rapid failure detection times between forwarding and also lower overhead. It is used to test connectivity between routes. It sends configurations to edges. So there is a vManager, and it connects to WAN edges. And there is like service side, transport side, and there between vManage and WAN edge there is a SD WAN tunnel, BFG, bidirectional forwarding. Bidirectional forwarding, when we measure latency, jitter, delay, loss, jitter, there are restrictions for iOS XE SD-WAN in controller mode. OMP. OMP stands for Overlay Management Protocol. Overlay Management Protocol is a TCP-based extensible control plane protocol. OMP runs between WAN edge routers, vSmart controllers, and between vSmart controllers inside authenticated TLS and DTLS connections. OMP for WAN edges, there are no required to peer with all vSmart controllers. Terminology for OMP networks. There is transport side. Transport side is always connected to VPN 0. Transport side handles all control plane traffic which is carried over OMP sessions in the overlay network. Traffic is always encrypted unless split tunneling is used. Service side. WAN edges interface is connected to customer and user network. VPN number 1 to 65,535. So here 512 used for out-of-band management. So VPN numbers could be from 1 to 65,335, and traffic is forwarded as is. Overlay management protocol terminology. TLOC. What is TLOC? TLOC is like a router IP. TLOC is a connection of information making up a transport side connection. So we have transport side, service side. Transport side handles all control plane traffic, and service side, it connects customer and user network. And TLOC is a connection between transport side connection. Its attributes are system IP. System IP is a unique identifier of an OMP endpoint. Then we have origin and name, site ID, color, private TLOC IP address inside net, public TLOC IP address outside net. Policies are applied to sites, and it makes routing decision about east-west. If this was a frame relay, then we could, for example, set up a service. But here, policies applied to site, and routing decision is about east-west. vSmarts advertise TLOC routes, and you can establish tunnels between endpoints of different colors as long as there is IP connectivity. TLOCs and colors. There are colors such as private colors. For example, private colors are MPLS, Metro Ethernet, private 1 to private 6. And the color for TLOCs is important and highly significant. Public colors, they are used for 3G and LTE. Biz Internet, public internet, public colors could be gold, silver, bronze. Colors could be like red, green, blue. Custom 1 to custom 3. Fabric operation is default. The color setting is applied from one WAN edge to another WAN edge to controller communication. Control plane authentication. So SD-WAN fabric authenticates all devices participating in network to secure the infrastructure. Control plane authentication, initial boot vSmart. Then software generates public and private keys. Administrator installs signed certificate. Then administrator installs serial number files. And digital certificates are used for authentication. What is DTLS? DTLS is a protocol, is a transport privacy protocol for connection-less datagram protocols like UDP, and it's based on stream-oriented TLS protocol. Control plane encryption and integrity. They use AES, I think Advanced Encryption 256 GSM encryption algorithm. It's high performance encryption. And control plane encryption uses message digest. SD WAN daemon ransom vSmarts and creates on exchange and digital certificates. And when ages, they create and maintain secure DTLS and TLS connections, data plane authentication and encryption. vSmart knows which VPN appears on each edge. Encryption keys. When edge routers only make control connections to the controllers and not to other edges routers. Once control plane connection is established, the public and private keys are used to ensure that packets have been sent by a trusted host and were not inserted midstream by an untrusted device. Data plane integrity and encryption. We put on each router window size, normal IPsec anti-replay, modifications to ESP protects the outer header, IP and UDP headers. It's like an AH, like AH stands for authentication header, protocol. Traditional IPsec like IKE, IKE stands for Internet Key Exchange, Infrastructure Key Exchange, which uses Diffie-Hellman key exchange algorithm to generate a shared key. IKE style key exchange doesn't scale well, and IKE could not be a bottleneck in maintaining exchange on a large networks. SD-WAN implementation of IPsec eliminates IKE, only ESP standard IPsec encryption protocol that protects the inner header, data packet, payload, trailer ESP. Operational mode change. Autonomous mode goes control mode, and operational mode exchange supports a single universal talks image supports two modes, automate SD-WAN controllers and autonomous automizes SD-WAN controllers. An autonomous mode is the default mode for the routers, and it includes iOS XE functionality. Autonomous mode enable option promotes user to choose either day zero mode to restore old configuration. So to turn it on, we need to put the command controller-mode enable. Router in controller mode enable, or otherwise if it's enabled and you want to disable, you put command on the router controller mode controller dash mode disable. So this way we go from controller mode enable and disable modes. And enable prompts user to choose day 0 or restore old configuration. Connect to vManage to set the required configuration. In controller mode, contents of NVRAM, non-volatile memory, and startup config is empty. Device is restored to day 0. Previous running config is stored in boot flash. So when we go from age to age, original YANG based, YA and G based SD WAN configuration and controller is preserved. Examine Cisco SD WAN deployment options. Implementing Cisco SD WAN solutions version 3.0. How to deploy the controllers, set up MSP and enterprise to use an enterprise certificate authority. SD-WAN on-premises deployment. Separate interfaces such as single vManage or several vManages, Cisco Cloud operations, MSP deploying MSP cloud, enterprise deploy in private cloud. vManage install process could be on-premises and cloud hosted. For example, cloud hosted on Amazon Web Services or in Azure. Obtain software and verify system requirements. Deploy the OVF template. Locate downloaded OVF template. A single interface, such as interface Ethernet 0, thick or thin. Edit virtual machine settings. vManage requires 2 virtual network interfaces. It could increase CPU, add second network interface. You can add a hard disk, for example, 100 gigabytes. Controllers must be IP reachable from vManage routers and other controllers. Perform database installation. vManage cluster change the password straight away. And I will continue later. Please let me know if these SD-WAN solutions you are interested to listen more. All right, it's time to go to sleep. Bye.